What? Getting back to the idea of pseudocode. Remember pseudocode, even though you can type it into idle, it's not going to actually run. So once you type it, don't expect to be able to hit the run button and have it do anything. You have to write Python script, Python code, for it to actually run. And I haven't actually assigned you any Python scripting homework yet. We've just done the pseudocode and the flowcharts assignments as and let's see, since the pseudocode was due last, when was it due?
Yesterday.
Yeah, so they haven't all been graded. I'll get them graded today so you can look at them. What I've seen in the past and in a couple of these is just some confusion over the idea of what you need to ask for when you're doing a program or pseudocoding a program. So if I write a problem like this, convert apples to oranges, and so I tell you, ask the user for the numbers of apples, tell them how many oranges they can get if the formula is oranges is equal to apples times 2. For some reason apples are expensive, so we could buy 2 oranges for every apple we get. Okay. So that's our, what I see people do is things like this. Input apples, input oranges, and then they kind of go, huh? You know, what is the South Park thing where, you know, you do 2 steps and then you do question mark, question mark, question mark, and then you do profit. All right, here's what we got to figure out here. You know, you really don't input oranges. That's what we're trying to figure out. The only thing we're doing is asking the user for the number of apples. So we're not going to be inputting oranges at all. The user is going to type in the number of apples. Instead, we're going to tell them. We're going to print. We're going to output. So that's what we need. Input apples. Step 2, then a miracle occurs. Step 3, output oranges. So, you know, generally your programs of this sort, especially the conversion problems, are going to be get input, and then they're going to be process input, or I'm just going to put process, and then display output, like that. So the process here is we have a number of apples, we want to display a number of oranges, we don't have a number of oranges yet, okay, that's going to be our process. And this problem happens to give us the conversion ratio. I didn't tell you to Google it up on the internet because I'm not sure what kind of conversion we would find for apples to oranges. So anyways, oranges is equal to apples times 2. Or if we want to follow the textbook a little bit more, we could say set oranges equal to apples times 2. But I don't care if we skip that. So I'm going to leave the word set off. Okay, so that is pseudocode that solves this problem. So breaking it down, you know, that's a very important piece here. Ask the user for the number of apples. Tell them how many oranges they can get. So that's an input. This is an output. And I know some of y'all get it. I'm not belaboring it, but some people need the reminder. And then that would be the processing step. So another case. Eventually you start running out of conversion problems. In my head. Alrighty. Write a program that will convert miles to feet. Say that was all I asked. I didn't get all detailed on it. We still need to figure out what we're going to input. We know that there's going to be 3 steps. Input, process, output. Okay, so if we want to convert miles to feet, that makes it sound like the miles is going to be the input. So input miles. To get to feet, that's our goal. That's what we want to tell the user. Output feet. And then our process needs to be some kind of conversion. Some kind of magic thing that says feet is equal to miles, and it's going to be times something or divided by something, you know. And then you can Google that up. Isn't it like 5,280? How many feet per miles? Yeah. Yeah. 1 mile is equal to 5,280 feet. So I could do this. Feet is equal to miles times 500. There we go. Like that. And that would be our pseudocode for it. And as I have been doing in the past, all pseudocode should start with a start. All of them end with a stop. And since so far every time I've shown you pseudocode, I've forgotten to do that, I'm not going to count you off if you don't do that, but please remember to, if you can. Okay, I'm going to delete that word process because this is the process right here. If I wanted to add comments, you know, input, process, output. Alrighty, and then stop. Flowchart wise, that would be really easy to do. You put an oval, that's the start. Then you put a tilted quadrilateral for the input. Then you do a rectangular box for the conversion. And then you do another tilted quadrilateral for the output. And then you put an oval for the stop. It'd just be a straight shoot. Straight shot down from beginning to end. Now these are the easiest kind of pseudocodes because they don't involve any looping or any decision statements, any if statements, anything like that. So if you don't get the conversion problems right, if I don't give you full credit for them, no worries. That's not your final answer. Just revise and re-upload. You'll even if I forget to say that in my feedback, usually I do. Usually I say something to the effect of, please revise and re-upload. But if you only got like 65 out of 100 because I thought that you only did 2 of the problems rather than the third, go ahead and do the third. Upload it. I think I'll go back through and modify all the feedback to make absolutely sure I said you can resubmit it. But that's just a general rule. Now, if the reason you didn't get a great grade on it is because the assignment was a couple weeks late, resubmitting it's not going to help that. But, yeah. If it's because your program didn't run or your pseudocode wasn't complete or whatever, then I will note the reason why and you can correct it. Alrighty, so we had talked about binary, we had talked about hexadecimal. Reason all this kind of matters is because ultimately computers deal with everything as numbers, and that includes pictures, photographs, that includes sounds, that includes the English text that we all type in. It has to be in numbers in order to be written to the disk, to be processed to the chip, and ultimately it's just all ones and zeros, So, today we're going to talk about how text is encoded. Now the way I'm going to show you is just a way that was chosen. It's not the only way you could do it. If you were going to make up a simple code, you could do this. A, B, C, D, E, F, G. Let's pretend that our alphabet only has those letters in it. And I don't mean hexadecimal now. We're not talking about A through, F being 11 through, these are 10 through whatever. We're just going to write some words. And this is not how they're actually done in a computer. This is just an example of the kind of thinking process that led to where we were today. Say we're going to do the words bad, feed. Let's do bead rather than dead. It's a cheerier word. Okay, and then Abe. These are the words that we want to encode in numerical turn into a series of numbers that could be written out. Okay, here's the easy one. 1, 2, 3, 4, 5, 6. All right, you know. So BAD, we're going to convert that. That'd be a 2, 1, 4. You know, it's kind of a grade school code. You want to write it, you know, a secret message and pass it to your friend, and then if the teacher intercepts it, they're not going to know why you wrote. Actually, even if they did figure it out, they would have no idea why you wrote bad feed, bead, Abe. But okay. And then feed. What would feed be? 6, 5, 5, 4. What about bead? Yeah. 2, 5, 1, 4. And so on. An A is a 1, a B is a 2, and an E is a 5. Okay. So what's the problem with this particular scheme? This particular scheme only lets us have 9 different letters. If we kept going, 10 if we count 0. Okay, 9. So that'd be a 7, 8, 9. Conceivably, I should have started counting, you know, with A is equal to 10. Let's use 0 as a space. You know, if you're going to have a space, that's going to be a 0, because you might want to write a series of words. You know, so if you wanted to write bad feed, bead, Abe, you just put zeros in between them all. So that's our little scheme. However, it's not very great. We only have 10 keys on this typewriter. We only have 9 letters and a space that we could use. Inadequate. So what could we do? We could use 2 digits rather than 1. We could say that a space is going to be a pair of zeros, and A is going to be a 0, 1. A B, you know, okay. So here we go. Now we can have up to, you know, 99 different letters. That's pretty adequate. You know, we have 26 letters, and then we have 26 lowercase letters. We have punctuation. We have, you know, numeric digits. 99 would cover them all. So, and so on. Hij, you know, is a 10. And so on. Okay. So now with all that kind of stuff, I can't think of any 3 or 4 letter words that have those and start with a J. Okay, so I'm going to go all the way out to L. Okay, so now we have a better coding scheme. The reason I'm calling it better is because, you know, we could do better words. Longer words. So using the 0 through 9 scheme, those would be our results. If we were going to use the 0, 0 through 99 scheme, let's say we're going to use the, you know, bad again, but we're also going to do, you know, lead, or just LED if we like Led Zeppelin. Okay, so B is a 0, 2, an A. In fact, let's encode the words bad space lead. So 0, 2, 0, 1, a D is a 0, 4, a space we decided was a 0, 0, and I shouldn't be doing this because then y'all are going to think that this is what's known as ASCII, which is what I'm going to spend a lot of time talking about next, which is actually how it is done in the computers. Okay, so, and then an L is a 12, and an E is a 0, 5, and an A is a 0, 1, and a D is a 0, 4. Okay, and so if you gave, you know, if you wrote this down as your secret code and then you handed it to your friend, you know, they could you know, turn it back into text, and they would wonder why you wrote bad lead to them. I'm going to rearrange this a little bit, cut that 0 through 9 and put it up here. Okay, so why didn't the people who invented computers use this scheme? It seems pretty simple to me. I don't really know the history of it, but they decided that, or they needed things other than letters and numbers and punctuation. They needed things like a character that would cause a printer to eject a page, you know, and another character that would cause, you know, the printer to go back to the beginning of the line. Why am I saying printers? Because the first computer output, you know, they didn't have screens hooked up to them. You know, you've seen those old teletype machines, you know, in movies or whatever, and you may have seen, you know, where you have a keyboard and it's actually hooked up to a printer, you know, instead of a, you know, a screen. So, you know, printer commands were really important. And then they added things like a code that meant start the transmission and then stop the transmission. And why would you need that? So that, you know, you would know when to stop reading this stuff. So you can make up another code where, you know, I'm just going to totally make up numbers. 88 means start. 89 means stop. You don't have to type this in because this isn't... Okay. And so if you were going to write bad lead, you'd stick an 88 in front of it to mean that I'm starting some text. And you'd stick an 89 at the end of it to mean stop. Okay. So we're going to switch over to something called ASCII, which stands for... Oh, gosh. Let me make sure I get the acronym right. American Standard Code for Information Interchange. And oddly enough, it gets used in a lot of places other than America. So, for whatever reasons, they decided that 65 was an A, 66 was a B, 67 was a D, 68 was an E. And then you could go all the way out to Z, and then there may have been a few symbols, and then they started with the lowercase. We'll pull up an ASCII table in a minute. So obviously there was room for a lot of other stuff. You know, all the numbers, 00 through 64, there were room for other things. Now, bit-wise, a 64 is a, okay, that's the ones place, that's the twos place, that's the fours place, that's the eights place, that's the 16s place, that's the 32 place, and then the next one's the 64. So I don't care if you know that, but if you have that many bits, 1, 2, 3, 4, 5, 6, 7, you can encode the numbers 64 like that, and then 111111 would equal all the way up to 127. So ASCII was originally 7 bits wide. You could have, you know, 000 all the way out to that, and then 100001 was a 65. And we could translate that the same way we were doing a couple days ago, where you say that's a 1, but there's no 2s, and there's no 4s, there's no 8s, there's no 16s, there's no 32s, but there's a 64. That way. So for some reason, they decided to make it so that all the letters were things that started with a 1 in that position, and everything else started with a 0 in that position. I do kind of want you to remember just that a 65 isn't, whoops, I'm going to put the star up here. A 65 is an A. I mean, I'm going to put 2 stars by it just so that you'll keep it triggered in your mind. Although, very, very, very likely, if I ever asked this on an exam, I would actually give you or tell you to go and access an ASCII chart. It would be kind of difficult for me to say that a test is open computer, open notes, open internet, but then somehow forbid you from looking up an ASCII chart. Okay, so let's go and look at one. This wasn't necessarily the first way of encoding it, and it's not the only way of encoding information as numbers, as characters, words as numbers. IBM used something else called EBCD, E-B-C-D, I don't know what it stood for, but they eventually switched over to using ASCII too. Even large, rich companies eventually have to adhere to other standards sometimes. And ASCII was derived from earlier teletype. Teletype was kind of like fax machines, except all they sent were text messages. You know, so you could get stock information, you know, from New York to LA or whatever. Kind of like telegraphs, except instead of they would actually send numbers, and the numbers, would represent letters, get turned into letters that would be printed out. So here's an ASCII table or an ASCII chart. If you go to Google or Bing and type in ASCII table or ASCII chart, you'll get one. You type image it, or you click the images button, you get a whole bunch of different ones to pick from. Some of them are pretty cryptic. Am I going to use that one? No, that one confuses the heck out of me. That looks like maybe it's a good one. Okay, so if we look at it, like I said, if I'm going to spell the word bead, bead would be 66, 69, BE, 65, 68, BEAD, like that. So if I type in BEAD in Python or in Text Edit, Notepad, something like that, and then I save it to the hard drive, somewhere on the hard drive are going to be the numbers 66, 69, and I know you can't actually see these at the back. I could zoom in on it. BE, 65 for the A, and then 68 for the D. Let's zoom in on it. And then there's these hexadecimal equivalents, and we're not going to worry too much about those during this part of the explanation. We may go back to that after a bit. So we see that not only do we care about letters, you can type in a whole bunch of stuff. The typewriter keyboard has a whole bunch of things. You want to be able to send somebody things with parentheses. You want to be able to send somebody spaces. Spaces are important. All the punctuation. Well, I won't say all of it because, there are weird forms of punctuation. Periods, dashes, whatever. Wait. Where'd my image go? I liked that one. Why'd you take it away from me? I really liked that one. Maybe Shift T will bring it back. No? Where'd it go? It was called Better ASCII Chart. Are you seeing where I had it? Okay, right there. Yeah. Sorry about that. Okay. So I'm going to kind of zoom in. You'll see that the very first things in the ASCII table were kind of, techie stuff that only the computer would worry about. Start of text, end of text, I mentioned that. End of transmission. When you were done sending, data to the printer or whatever, you might send an end of transmission. Another one, bell. You could make the printer beep a million times or whatever in order to annoy somebody. Backspace, because you have a backspace key on your keyboard, you'd want to, be able to backspace. And everything gets translated into these numbers for them to be processed by the computer to update, the printer or the screen or whatever. New line, if you wanted to put a whole bunch of blank lines, it's in a series of 10s. Vertical tab, that's a weird idea. Horizontal tab, that's somewhere else. Character chart. On DOS, the oldest IBM PC and Microsoft operating system, you had to store data with both a CR and an LF. Character chart would just send the cursor back to the beginning of the line, but it wouldn't skip to the next line. It'd be like, I don't know what it'd be like on a typewriter. And it's like you hit, the return button, and instead of going to the next line, it just went all the way back to the beginning, and then you had to roll the roller up. How many people have even ever typed on a typewriter like that? And then, so there was a line feed, new line, and then there was, or character turn, and then new line, or line feed. That's what the LF stand for. These little things in red are short little abbreviations for these things. We're not going to care about those ever again. But we do want to find the punctuation. Here we go. So we have some punctuation. We want to write out the words. Let's come up with a phrase we want to write. I love eggs. So, I am going to switch to using a hexadecimal version rather than the decimal version. They mean the same thing, it's just one is encoded in hexadecimal as we talked about on Wednesday. Okay.
How would you distinguish between the, like, 32 and
I would ask you if I want you to write out the series of numbers as decimal or if I want you to write the numbers out as hexadecimal.
like let's say you had, like you didn't put spaces in between it, you just left it like all together. How would you know each one? Since some of them are like what's it called? One place, some of them are two places, some of them are three. Like there's no zeros in front of it.
Right, the zeros was part of a different example.
But I'm saying, how would you know which one was different? Like where one ended and where one started? Since they're not all the same amount of numbers. Like where would you put it?
Okay, I see your question. Very good question. Like if I asked you to write a word and some of them had 2 digits,
Yeah.
99, and then some of them had 3, like 100. That's why I'm switching to hexadecimal. Because in hexadecimal, all of these are just 2 digits. So you can assume that every pair of numbers, or numbers and letters, represents one character. That is an incredibly good question. I'll show you what she meant. What if you typed in something lowercase and you wanted to type the word man, M-A-N, okay, as decimal numbers? M is a 109, A is a 97, N is a 110. How would you know where to break it up? You wouldn't, unless you came up with something that took up extra space, like putting 2 zeros between everything, or something like that, in order to show. And so that's why we're going to use the hexadecimal. Every, all the way up to even Z can be encoded in just 2 hexadecimal digits. So I've been giving all my examples in decimal because it was easy for us to understand at the beginning. Now we're going to ignore the decimal column and start using a hexadecimal column.
On the hex, you basically just look at the last 2, because it looks like everything has a 0 hex.
That 0x is a wonky way of saying this number is a hexadecimal number. And so, right.
It's just notifying that
it's
hex.
just,
okay.
Right. You could have left that off and it would have been a valid hex table. And so if I give you one of these on an exam that I want you to use, I'll probably take those 0x's off.
Okay.
Because otherwise you might be tempted to put them on every letter.
Is that for the machine to recognize what that is? Or is that just
That's
like the formal version of writing?
It's kind of like a formal version of it. And a lot of programming languages will let you input hexadecimal numbers so that you could say eggs is equal to 32, but instead you would put eggs is equal to OX20, and it would mean the same way. It's just a way of distinguishing between the numbers. When I were writing the numbers on our stuff earlier, I distinguished them by saying base 10 and base 16. So you had the number 55, base 10, and I'm going to cheat and come over here, and a 55 is equal to a, oh come on. Why are you doing that? I am not understanding what I'm doing that's getting that to happen. Okay. Anyways, that represented that's a decimal number, and then, this represented, because otherwise you wouldn't know whether 77 meant one thing or another. So there had to be some way of doing it. We're going to ignore the 0x's in front of everything. So I want to encode the word I love eggs with an exclamation mark. Okay, I'm going to be even weirder and put quotes around the word. I don't know why. Maybe I don't really believe that's how you spell eggs. So here we go. We need an I. If you have this chart open, tell me what the hexadecimal number for an I is. Is it 49? Okay, well, let's verify that. I kill you. All I'm doing is tabbing between that and that. Whoops.
Well, left click the mic.
Okay.
Well, magnifying glass came up. Yeah, click the back stick.
I blame my keyboard. Okay. Yeah, I see that. I see the
Click it zooms in and click again, it'll zoom back out.
Well, there's that one. Okay. 49. And then, you know what I'm going to do is I'm going to space this out so that every one of these takes up 2 characters, because I'm going to be, firstly, I'm going to make it shorter. Bad dad. Okay. There's a reason I'm spacing it out like this. You'll see real fast. A B is a 42. An A is a 41. A D is a 44. A space is a 20. A D is a 44. An A is a 41. A D is a 44. And an exclamation mark is a 21. So if I wrote out bad dad in all caps, stored on the hard drive, stored in RAM would be these numbers: 42, 41, 44, 20, 44, except there would be no spaces between them. So let's say, also known as, I'm just going to take all the spaces out. This is what's on the hard drive, like that. Right. I'm completely ignoring all those control characters. I'm just worried about the text itself. Okay, so let's see if we can demonstrate that. I am going to create a document. Let's save these as our notes. And I'm going to write bad dad in it and save it to a file. So I need to pop open Notepad again with a fresh document. Bad dad. Okay, then I'm going to do a save as. I'm going to call it baddad.txt, just so it's easy for me to find later. Okay, and then I'm going to use that hex editor that I showed y'all. I think. Hex, maybe I didn't. Hexed.it brings us up this tool for looking at files and showing how they're represented in memory. So I typed in hexed.it, I do open file, I go to baddad.txt, it loads it up, and we see, although I can't really zoom in, I apologize guys, thought I could. BAD. Hex editors, or this one is displaying spaces as periods. Sorry about that, that's really a space. DAD, exclamation mark, and then we go and we look at the numbers. 42, 41, 44, BAD, and then spaces are 20s. And then DAD, 44. We can kind of see that every D is a 44. Now, is this, quote, encryption? No, it's not encryption. Because encryption, the goal is to make it unreadable, except for anybody who knows, the method to decrypt it. And so that's an entirely different topic, or maybe not entirely different. But this is just encoding. The words code and encrypt sound very similar, but you just have to have some way of turning letters and punctuation into numbers to write to memory. And this is the way that it works. This is the way that's been standardized. So if I went over to the text editor and I made some changes here, like I decide that dad isn't bad, he's a cad, I could look up what an ASCII C is. It would be one more than 42, because A is 41, B is 42, C is 43. So I could do a 43 there. And now it says cad dad. So when I used Notepad, it created what's known as a text file. That's what Notepad does. And that's also what idle does. It just creates a text file. A text file is a simple file that's encoded in ASCII, and you could mail it to a Mac user, a Linux user, you know, anything, and they'd be able to open it, and they'd be able to view it, they'd be able to understand it. So this is a very commonly used file format. Is it the only file format? Well, obviously not. This would not work for an Excel document. Word documents are not encoded as text files because Word documents need, you know, to be able to make things bold and italics and have column headers and stuff like that. I almost had another point to make. It slipped my mind. Web pages, though, are saved as text documents. If I'm looking at a web page, here's a web page, Google, and I do right-click View Page Source, that is all text. So it is stored in ASCII somewhere on the hard drive of a server, or at least generated by a program and then sent over the internet, and then your browser opens it and reads it and draws a web page based on it. That is also ASCII. Okay, I don't know if I need to do another example of that before I ask you to do some. I'm going to come up with some other words. I would like everybody to open an ASCII chart on your computer. Pick a reasonable one. If you open one and it looks kind of like that and it's confusing, I wouldn't pick that one. Just pick the kinds that have, bless you, that have, symbolos. Is this written in Italian? I don't know. Anyways, you need one that has hexadecimal numbers, one that has the letters, and that's pretty much it. So you can kind of poke around until you find which one you want. Or I could post a link to that one that we have been using here. Why don't I do that? Yeah, why not? That'll let y'all come in and change your grades. Save the password. Always a good idea. Okay. Call it a chart. Don't know why I capped it all. Alright, if you go into D2L, then you go to our contents, or you just come over here to Content Quick Links, Notes, Week 2, ASCII chart. It should open the one that I've been using. And if you need to zoom in, Control plus the up wheel will zoom in. Let's do one more. I'm going to type in row state and encode that in ASCII. So Notepad, get my notes back open. And again, on mine, I'm going to put each one occupying 3 spaces so I could write it out as a sequence of numbers like that. R, I'm going to be sneaky and use some lowercase letters. O, S, E, followed by a space. S, T, A, T. I'm not terribly convinced that I got the right number of spaces there. I may have to fix it. Okay. That's looking wrong. Maybe it was right. Okay. Now I'm going to encode it. I have to figure out what a capital R is. A capital R is a 52 in hex. A small, a lowercase o, is a 6F. A little weird thing to notice is that if an uppercase R is a 52, a lowercase r ends in the same number. It's a 72. If a lowercase o is a 6F, then an uppercase O is a 4F. Just kind of interesting. You're saying, no, it's not, teach. All right. An S is a 73. And an E, lowercase e, is a 65. And a space is a 20. I just remember that. It's right there. A T, or excuse me, a capital S is a 53. All right, I'm kind of belaboring the point there. What I would like for y'all to do is open up Notepad, open up a text, an ASCII chart, and I want you to encode the phrase Python, and I'm going to put periods rather than spaces. Why? Just because I don't want that rigmarole of having difficulty spacing things out. Is space cool? I would like for you to encode that. And if it makes it easier for you, put 2 spaces between every letters. Before you go. So you can type this in Python in idle rather than Notepad. Just make a new document. You know. Go into idle, click new file. You can do it in Word, I don't care. Anything that lets you type stuff in. In a minute I'll do it as well. Encode the following sentence in hexadecimal ASCII. We'll get to that. Alright, for the people watching the video, I forgot to show the series of numbers. We did the word Python. The rest of these are left for you to do. What I really ought to do then is, you know, in the computer they would be stored like that. In a computer they would really be stored as 1s and 0s. Not going to bother.
So is it like something that takes that and converts that to 1s and 0s for a machine? Is it processing something or
yeah.
just translating?
For example, if we go into the calculator, we click View Programming Calculator, and we say we want to do this in hex, we ought to be able to type that number in, 5079. That's hard to read. I'm going to 74 68 6F 6E, and then click binary. It would translate it. Right. Right. I'm sure there are other ways. If you went to Google and do hexadecimal to binary, you'd probably find the very top hit. 5079. Whatever. Oops. Convert. And there they are. Except they're broken up into little clusters of 4 to make them easier to read. Here's an example of using that parentheses 16 to represent the hex. To warn you, to flag that it's a hex number, whereas that chart was using OX in front of it.
But I mean, if we saw a letter in there, an A through F, we would probably...
That would give you a really strong clue. Right. If somebody says, okay, I have 3 AF eggs, you probably know that they're an incredible nerd because they're telling you the hexadecimal version of the number of eggs. All right, guys. I think our brains may be warped enough by that. Let's take a 5-minute break. If you need to use the bathroom, get a drink. I think I posted something to this effect on the notes in D2L, but you know, if you upload something and then the day of class, rather than the night before, you realize you needed to do something and then you upload it again, I give you that day grace period. If you upload something Wednesday rather than, you know, Tuesday night, you're not going to earn the 5% bonus credit, but you'll still get 100% on it. And maybe that's what you were asking. Yeah, that is what you were asking, actually, I think. So you're still going to get full.
If I turn mine in late, that's what I was asking.
Right. So I'm not counting it as late because you got it the day after. I mean, right. You got it today. Well, let me show you where I posted that. I'm not trying to be confusing. I try to be nice about due dates. Make it so you get a little bit reward for turning it in by midnight. But if you have to ask a question about it, you know, the following day, or you lost the file and you need to upload it or whatever. So all that stuff was listed here. Homework turned in before or on the due date, you know, midnight by Tuesday, get a 5%. I don't know why it says due date, a 5% due date. It should have been 5% bonus. Bad writing. If turned in on the day of class, there's no penalty, no bonus. After that, deductions start accruing. That makes sense? Okay. So, I forgot to make us do it the other way, where you had some hexadecimal numbers and then you go to the text. So, I thought we were done with ASCII for a moment, but we're not. I'm going to give y'all one. Make it short. Yeah, for Pete's sake. Okay. Alrighty. Tell me what these numbers mean, and I'm going to put spaces between them. 48, 65, C, 6C, 6F, 3F. Alrighty, on to I know we've already done binary to decimal and vice versa. I don't think we did binary. I want to revisit the topic. So if we have these numbers 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0. Now it gets tedious. Then I copy and paste those so that I can cheat. That'll be 8 of them, but I'm going to do 16 of them actually. So anyways, that's obviously a 0 in decimal. And so it's obviously a 0 in hex. That would be a 1 in decimal. That's a 1 in hex. That's a 3, and that's a 3. That's a 4, and that's a 4. And if I wasn't doing it by counting, you remember how to do that. That's a what? There's a 1, but there's no 2s, and that's a 4. There's no 8s. So 4 and 1 is a 5. Not a 6. Where'd that come from? All right, now this is going to be even more tedious because I'm trying to put it in a table. 1 0 0 0. 1 0 0 1. 1 0 0 2. 1 0. What a 2? That's not binary. Alrighty. What's next?
1 1 0 0.
Yep, 1 1 0 0. 1 1 0 1. 1 1 1 0. 1 1 1 1. Okay, so we've used 4 bits. We have put all the possible variations of 4 bits. That's an 8, which is a hexadecimal 8. That's a 9, which is a hexadecimal 9. That's a 10, which is a hexadecimal what? What's the first hexadecimal? A. Yep. 11 is a B. 12 is a C. 13 is a D. 14 is an E. 15 is an F. Okay, so there is our little chart. That's binary, or maybe just bin. That's decimal, that's hex. Binary, decimal, hex. If I ask you this sort of question on an assignment, or quiz, or exam, or anything like that, I'll give you this chart so you don't have to take 5 minutes and write it down yourself, or Google it up, or whatever. The reason I will do that is if I say convert, FF01 to binary, I don't want you to have to figure out what FF01 is in decimal, which you could. That you have 1 plus no 16s plus 15 times 256 plus, whatever. That's kind of nasty. It's not hard. It's tedious. But if you have this chart here, you can do it just like this. What's an F? Well, lo and behold, it's a 1 1 1 1. What's the second F? Oh, it's going to be another 1 1 1 1. What's a 0? It's 0 0 0 0. What's a 1? It's a 0 0 0 1. There. It was that easy to convert hexadecimal to binary, like that. That's one of the reasons why hexadecimal became a thing. It wasn't just created out of thin air in order to... It was used because the computer scientists had zeros and ones in memory, and they wanted some way to represent it on screen. So, in an acceptable format, and I'll tell you what I mean by acceptable format. What if I had these numbers? I'm going to space them out now. I'm just making these up off the top of my head. I don't know what it's going to result in. Okay. And then I wanted to convert those to numbers to display, on a screen. Okay. But I hadn't invented hexadecimal yet, so I might encode these as decimal. A 1100 is a 12. 1101 is a, I almost said D, a 13. An 0010 is a 2. An 0011 is a 3. And a 1110, I'm going to make this a 0001 just to prove a point instead, which is not a 2 but a 1. I think I'm going to stop there. Okay. So, that's fine. If I was trying to display this on a screen, that's base 10, I might display it like this. I want to get as much information on the screen as possible. But when I'm looking at it, I want to be able to figure out what the bits are behind it. You know, we're talking like 50s style, really early stuff, and so we're not going to have big monitors, you know, with numbers on one side and the bits on the other and windows we can drag along. We just have a page full of numbers, but we might want to be able to visualize the bits behind them. Okay, so a 1, 2, that means a 1, 1, 0, 0. And this is actually the question that you asked, pretty much. And a 13, 1, 0, 0, 1. And then, oh, I got another 13. That's a drag. I don't know whether it's a 1, 0, 0, 1 or whether it's supposed to be a 1 followed by a 3. So you think, well, you could figure that out. You could just put zeros in front of everything, you know, like that. Well, that's great and all, but now we took 8 spaces to display what took 4 spaces in hexadecimal. So hexadecimal was just a more efficient way of displaying the data. You could get twice as much on a page. You could get twice as much, you know, on a screen. That's what hexadecimal is used for. If we were using that Hex Editor, if we didn't have such thing as hexadecimal, then when we were looking over here, every one of these columns would have to be 3 digits wide rather than 2. At least. I think that's correct. Okay, so I'm going to delete this one because this was just an example of why you would want to use, you know, hexadecimal to display data rather than base 10. Even when to us laymen it seems, you know, harder. Okay, I'm going to ask y'all to convert 2 more things. Convert FE90 to binary. I'm going to leave the chart on the screen and convert 1101 11 1001 0010 0001 to hex. And this hardly requires any thinking at all. You just use the table. And F is a 1111 and so on. And I don't care if you put spaces or not. All right, I've seen several hands lift off the keyboard. And F is a what? 1111, and E is 1110. I can put spaces between them to make them easier to read. A 91001, and a 0 is just all zeros. All right, I've gotten too much on here. A 1101 is a D, and I just made these up. That's not going to spell a word or anything. A 1001 is a 9, and an 0010 is a 2, and an 0001 is a 1. Okay, that makes sense, guys? Alrighty. But I just want to learn the program. Why are you doing all this to me? Because you may get to some point where you need to write a little conversion routine that'll convert one to the other. You need to be able to pop open a Hex Editor and to look at a file to understand what's going on with it. You just kind of have to be fluent in this stuff. It's like we're learning how to pronounce the vowels before we go and we learn English words. You have to know what a B is, blah, and what an X sounds like. Alrighty. I'm going to give you one more example of this kind of stuff, but we're not going to actually do conversions or anything. If you have, like, I don't know, a JPEG. Let's find some pictures. Puppies. Puppies ought to be a safe search, right? Okay. Here we're... Is that a JPEG or is it a PNG? Okay, puppy JPEG. I want these all to be the same type. Okay, so I'm going to save this puppy. I'm just going to call it pup1. Now let's look at another pup. Save as. Call this one pup2. Now let's open those files in a hex editor. File, open file. There's pup1. Now let's go to hex edit over here. I really wish I could zoom in, but it's not letting me. It's got so much information, I guess. Hexed.it. Open the other one. Load up pup2. Now if we toggle between these two, dadgumbit, not even let me resize it. Since when can you not resize windows? Okay, I'll if you look at it over here, apparently JPEGs all start with a FF. I scroll over here, FF, and then they start with a D8 and a D8, and well, FF D8 FF, FF D8 FF. So the first three characters maybe are what flags a file as being a JPEG. And you may say, well, the extension also indicates that it's, a JPEG. But if a program opens a file and sees these three characters, it might be able to make the assumption that the file is a JPEG. Now I'm going to go find a couple of puppy GIFs.
My JPEG was almost exactly all the way down the first one.
I'm half deaf. Pardon me?
No, I was just saying I picked a different picture,
Oh, yeah?
and the first line was almost exactly like one of the pictures.
Yeah. That's because this is the first part of the file is what's known as the header of the file. And the header of an image file has to have a couple characters that tell it. I wish I'd used your puppy because I wanted them to look very similar. And the two that I did only had, a first couple of characters that would have saved. But the header of the file, the first couple of characters will say, oh, by the way, this is a JPEG. And then there'll be information like how many pixels it is wide and how many pixels long it is. It might have another marker that says, y'all have probably heard of EXIF information. Whenever you take a photograph, it encodes, what model camera you use. It might store your JPEG, your GPS information. If you email somebody a picture you took, it's possible that they'll be able to figure out where that stuff came from, or where you were when you took the picture. All of that information is stored in the photo itself. One of these looked like it had some EXIF information. EXIF. If I find an EXIF viewer, EXIF viewer, I might be able to figure out where that picture was taken. Chrome Web Store. View EXIF. I don't want to do it that way. Oh, what for? Party pooper. Alrighty. Online EXIF viewer. Drop an image file here, or select. Okay, let's go find pup2. Loads it up. Okay, it was taken with a Sony. The model was here. Now this one's not showing GPS coordinates. If you're ever worried about sending somebody a picture and you don't want the GPS information to be stored, take a screenshot of that picture. So, I take a picture view, but I don't want them to know where we were when we took it. Then I could load that picture up. I could take a screenshot of it. Every tablet or every computer has a way of taking a screenshot. And then you can mail that one to somebody and they wouldn't be able to figure out your GPS information. GPS, of course, meaning, where we were at the time. So lots of pictures have EXIF information. All of that has to be encoded in the header as well. The number of colors in it, whether is probably in the header and so on. We could do a similar exercise using MP3 files, musical files. We would see that every MP3 file starts off with a certain sequence of characters, and then there's other header information which we wouldn't be able to read, but it says things like, how many bits it is. You may have seen that, some MP3 files are 256, some MP3 files are whatever, and also the title of the song and the album and all that extra information is all in the header. And sometimes, well, especially if you're working, with low-level files or whatever, you'll need to know how, just kind of that concept. Just kind of that concept. All right, I think it's about time for something completely different. Let's go back to those conversion problems that we did up here at the very beginning. Apples to oranges and miles to feet. That's our pseudocode. Let's actually write programs to do them. So take that start and I'm going to copy this stuff. And paste it into a Python, or just go up to idle. New file. My name, my date. Don't just put your first name. Conversion programs in class. Alrighty. Now I'm going to paste all of that stuff, but then I'm going to comment it out. The only reason I'm doing this, I could comment it out automatically with this format thing. It says comment out region. I could highlight a section of code like that and do format comment. Okay, put two things in front of everything. It didn't look nearly as good as what I was doing. What I really wanted was just this stuff here. That's the good stuff right there. I want to turn that into an actual program. So, converting pseudocode to Python. One thing is, leave off the start and the stop. So we're not going to put that. Input becomes something like x is equal to input question, whatever the question is. And if x, or whatever you're doing, is a number, you have to convert it. Like x is equal to float x, or x is equal to int x. Then do the processing. It's just going to be some other equation. And lastly, output becomes, or output is a print command, like print. Okay, I am going to put a processing step here just so that I'm continuing my thing of having examples. So print quote y equals, comma y, like that. If I can make these separate colors, I would. Be kind of cool. So that's the sequence we're going to follow. So we skip the start command. Now we need to input apples. So apples is equal to input how many apples. We just did that. I think I'm going to put letters in front of these steps. We just did A, B, and then C, the conversion to a number, and then D, the formula, and then E, the output. So we've done A and B. C, if it's an X, if it's a number, we have to convert it. Apples is equal to float apples. I could use INT, assuming that they were going to type in a whole number of apples. You know, if you ask somebody to go buy apples, you're probably not going to tell them to buy 6.5 apples. But somebody may want to be precise, so I'm going to use float so that they can type 6.5. Then I do the processing. I gave us an equation. Oranges is equal to apples times 2. Oranges equals apples times 2. I put more spaces in it than y'all necessarily need to. And print. I'm outputting oranges. That was my goal. Oranges equals, quote, oranges. Okay, so that's the Python version of our pseudocode with a whole bunch of comments. Do I want you to have all these comments when you turn in a program? No. At most, you know, you could do this. This program converts apples to oranges. The formula is oranges is equal to apples times 2. That's enough commenting for this kind of thing. These straight conversion programs do not require a lot of comments. If you want to put the pseudocode into Python, that's fine. Why did I put the pseudocode into Python? So I wouldn't have to keep tabbing between documents, you know? It's not a bad way to work, having your pseudocode right there. And I'll give another example of that when I get down to the next part. For the next part, I think I copied it as well, but I'm going to delete everything except just for the pseudocode. So, write a program that will convert miles to feet. There's my pseudocode. This stuff. Again, I'm going to comment it out because Python is not, you know, pseudocode is not Python. These statements would give error messages, syntax errors. Okay, comment all that out. Okay, now instead of writing it underneath it, I'm just going to put lines of code right there after the comment. Input miles. What would be a good way of inputting miles? I'd use an input function. What should I call my variable?
Miles.
I can think of an obvious one. Yeah, miles is equal to input, quote, how many miles, end quote, in parentheses. I keep meaning to do that. What do I need to do next? And by the way, I make mistakes. What I often would do, oh, and I should have tested the other code before we went on. You should test early, test often. Don't wait until you've written 100 lines of code before you actually start testing your program. Start small, build big. That way, you know it's perfect at every point.
You need to assign miles a value.
Right, I need to convert it to a number. Usually when I'm up here typing code for y'all, I forget to do that and I just type the equation. Feet is equal, you know, whatever. But that's not going to work because miles isn't a number yet, it's a string. So, miles is equal to float miles. Now people actually commonly think of 3.5 miles. It absolutely makes sense to make it a float rather than an int. Alright, so I've done the input step. Now feet is equal to miles times 5280. Well, feet is equal to miles times 5280. That looks dumb, but if I'd used the pseudocode convention of having everything, begin with the word set like that, it'd make a little more sense. Okay, output feet. What Python word do I use for output? Print. Feet equals, end quote, comma, feet. Do these things have to be the same thing? No. I could put your answer in feet is equal to whatever, The stuff in green is just text. It's to display to the user to tell them something. You could put anything there. You could write it in Spanish. You could leave it off, but then you're just printing out a number and they don't know what that number is. Okay, I need to save this and test it out. So I'm going to do a save as, put it in the 1113 directory. I'm going to call this conversion June 14, just to something. Give it any name you want. Just give it a name that you'll be able to find to upload to the Dropbox in a minute. So I'm saving it. I called it conversion June14.py. And oh, by the way, if you are creating your pseudocode in a rather than Python code, if you do save as and save it as a text file, it's a little bit easier to deal with just down the line. Not for me. I'm totally cool with opening a py script. But some of y'all may have noticed that if you double click on a py file, it tries to run it. And you get syntax errors. It pops open the black screen. You don't get to edit it. And the only way you can edit it is maybe your computer has a right-click edit and idle thing, or maybe you have something else that'll edit it in Notepad. But otherwise, you have to open idle and do file open and then go to that py file. But if you save it as a text file, then you can always come back and just double-click on the file, and it'll open it up in Notepad, and you're good. But this is an actual script, so I'm going to leave it as a py file. Let's run it. How many apples? Oh, I have a bushel of apples, and I have no idea what that consists of, so I'm going to say 100. And due to the conversion ratio, oranges are apparently cheap. I think it's vice versa, isn't it? Then 100 apples would buy us 200 oranges. How many miles? Oh, I don't know. We're going to drive 100 miles. That's 500,000 feet. And apparently I had a line of pseudocode in there that I didn't comment out. Stop, so it gave me an error at the end. I need to go find that. Yep, there it is. Alright, I want to make sure everybody got this working, so I'm going to pause. Let me give y'all another conversion problem or two. I'm going to put these in comments. That's kind of annoying to have to do, isn't it? We'll stick with it. We're going to write a calculator. Calculator. That's a big pun. I want some laughs out of it. Okay. Thank you. Okay. I'm going to put an applause sign up there. Okay. So, one cow produces, I don't know, 30 gallons of milk a day. I have no idea if that's right. Convert cows to milk. Write pseudocode for that, but then also write a program that'll do it. So put your pseudocode in the little comments, so that it won't cause syntax errors, but then actually write some Python script.
Set one of those variables to float, but you don't set any of the others. Because I know in some other languages, don't you have to set the individual variables to integer, float, or?
Right.
It's
Some languages.
It's
Some languages you have to predefine your variables. If I was going to write this program in C, I'd have to do this, or float latinum, float credits, and then, yeah, but this language does not require you to predefine them.
So if you set latinum to float, but you don't tell it anything about the others, does it automatically assume because it's calculating with floats?
Exactly.
This is going to be converted to floats?
Right, latinum is a float, it's multiplying it by a number, so it thinks that a number times a float is a float. Right. If you were super worried about it, you could add the float keyword there, like that, but you don't have to.
You said it was a comparison of standard.
Yeah.
Could you also just add float before the input?
Yep, exactly. You will see this a lot on the internet. You don't have to do x is equal to input, enter x. You could do this, x, and then, well, x is equal to float x. That's one way of doing it. It takes two statements. Or you could do x is equal to float, parentheses, input, parentheses, enter x. That works as well, and you're doing it in one line rather than two.
I think the second way looks neater.
Yeah. It's kind of cool because at least it's a one-to-one correlation with your pseudocode. All right, gang. That's it for class. Feel free to work on the other two problems in the homework.
Homework 3 is the pseudocode we did in homework 1, right?
It's writing Python
Yeah.
for the pseudocode for 1. Right.
Okay.
And if you've already done it, just upload it again. I haven't written a document that says that. I'll upload a Word doc.
What were we supposed to upload for Dropbox app?
Let me look.
X and X.
Yes, test and
All right, F was when I was asking you to do that binary to hex and that hex to ASCII. So if you didn't do it, if you did it on paper, just upload a file that said I did it on paper. Is that cool? I know some people like handwritten notes. Yes, sir. Now that doesn't work for homework assignments, but for equal,